Hello, today we are going to discuss another advanced algebra lesson. It is about the function, domain of a function, and range of the function, or it can be assumed as a pre-calculus lesson. So let us go towards this and see what is a function. Now let's see how we are defining a function. Okay, now before discussing about function, we have to see what is a mapping and a relation between two sets. So we are having two different sets. One of them we call the domain, and the other one we call the range. Now you have got two sets here. The first one I call it the domain of the function, and then the other one I will call the range. Therefore, this is the domain, and this is the range. Therefore, there are elements in the set domain. Suppose 1, 2, 3, -1, something like that. And range can be anything. For example, A, B, C, D, E. Okay. Now, a relation means you are relating every element of domain to some elements of range. Okay. Now, therefore, this is a relation between these two. This is a relation. Okay. This is a relation from this set to this set. Therefore, this is a relation. Suppose 1 is mapped to A and 3 mapped to B and also 3 mapped to D, and -1 has mapped to E. And 2 is mapped to C. And suppose -1 also mapped to D. Okay. Now, if we call this relation, suppose R, the name of the relation, we know that 1 is mapped to, using R, mapped to A. Or you can write this, R act on 1, the answer is A. Now, if R acts on 3, what is the answer? Okay, we don't know. Maybe B or maybe D. Therefore, there are two answers for this. We are saying this relation is not well defined or is one too many. Okay, one too many. If it is one too many, it is not a function. That means in function we want everything to be well defined. Every element of domain should be well defined. You see, 1 is well defined. When I'm saying relation, what is image of 1 under this relation, everybody says A. But if I say what is the relation, what is the image of 3 under this relation, you may say B, another person say D. Therefore, it is not well defined. We don't know the clear answer. That is, we don't want this confusion. That is why we are defining function, a kind of relation which image of any element from the domain is only one answer. Okay? Now, so function is a relation which is 1 to 1 or many to 1. 1 to many is not a function. let me write this note, then after that we discuss what is the meaning of this. Note that one to many is not a function. It is a relation, but not a function. Now, what we mean? What is the meaning of one to one, and then many to one? You see, if you have a function, suppose you have a relation. Suppose you have got 1, 2, 3, and 4, and here you are having 1, 4, and 9, and 16. You are saying 1 goes to 1, 2 goes to 4, and 3 goes to 9, and 4 goes to 16. What is this? This is a one-to-one function. That means every element of domain is mapped to only one element of range. Therefore, there is a one-to-one correspondence. Therefore, every element here has got one image there. Clearly, one image there. And that image is especially for that element of domain. Therefore, if this is domain, and this is the range, and this is our function, suppose f. Now, look at this. We can look at another one. Suppose you have got 1, -1, 2, -2, and you have got 1 here and 4 here. You can see that this image is this, image of this also suppose is this, image of this is this, image of this is this. What is the image of 2? Is 4. What is the image of -2? Again 4. It doesn't matter. We said every element should have one image. Every element here has got one image. But some of the elements have same image. That is well defined. When I'm saying 2, everybody answers 4. If I say -2, everybody answers again 4. That does not make any confusion. If here, at the first thing which we said, this is not a function, it's a relation, when I'm saying 3, image under this relation is either B or D. So that is a issue. If I say -1, you may say D, another person may say E. That is the confusion. So this is not a well-defined relation, or it is not a function. So in function, everything is clear. Now, this is the second one. The first one here we discussed is one-to-one function, and this one is many to one function. Therefore, we understood what is the many to one function and what is one to one function. And one to many is a relation but is not a function. Now, usually in mathematics, we are considering, especially high school mathematics, we are considering relation between x and y. Therefore, x is from domain, y is from the range. Therefore, every x you can have at most one y, not more than one y. Let's see, now we have a graph here. Okay. Now, I will draw different graphs with different colors and tell me, is this a function or not? This is one. The green one is another. The red one is another. And the black one is another. Now let us discuss one by one and see which one of them is a function and which one of them is not a function. Now look at the green one, the first green one. Now green one, you can see that for every x, suppose x is here, y will be this much. If x is here, this will be the value of y. For every x, you can see for every x you are going to get only one y. Therefore, the green color this is a 1 to 1 function. Now let's see what about the blue color one. Blue color one, you can see that for every x you are going to get one y. For this x also you are going to get one y. For every x you are going to get one y. But you can see that this, suppose this x has this y and this x somewhere here having same y. Therefore you can see that these two having same y. Therefore it is many to one function. Many to one function. Therefore, there are different x's having same y. That means if you draw a line parallel to x-axis, you can see that 1, 2, 3, three different x's having one x here, one x here, and one x here having same y. Therefore, the red one, the blue one is a function. This is a, what kind of function is this? Many to one function. I didn't write the e's there. This is an 1 to 1 function. This is a many to one function. Now let's go for the red color one. Red color. Now if I choose 1x here, then you can say you have got 1y here, 2y, and 3y's you have got. Therefore 1x has 3 different y's. Therefore it is not well defined, or it is one to many. This is a 1 and 1 to many relation. Not a function. Is that clear till now? Okay, look at the black one, the last one, the black one. Black one, how is the black one? Black one is actually a straight line, and you can see that it's 1 to 1. Every x you are choosing, you are going to get only y1. If you are choosing any line, draw parallel to x-axis, only one point of intersection. You can do that everywhere. You are getting 1 to only one y. Therefore, every x has exactly one y, and every y has got exactly one x. Therefore, this is a 1 to 1 function. This is an 1 to 1 function. So, you understood what is the graph of a 1 to 1 function, how it looks. I will remove some of these lines so that it won't be so much of things, so we can see everything more clearly. All right. Now, you see, and one example. Given that f is equal to 1 goes to 2, 2 goes to 3, 3 goes to -1, and 5 goes to 2. Is this a function? What is f of 2? Now, as I told you, we are considering always this is the first coordinate is x value. That means the function is given on this, and therefore the function acts on the first coordinate, and the second coordinate is the answer of that. Therefore, when f acts on 1, you are going to get 2. When f acts on 2, you are going to get 3. When f acts on 3, you are going to get -1. If f acts on 5, you are going to get 2. So you can see that there is no elements in domain. What is the domain? I can write the domain. Domain is the set of 1, 2, 3, and 5. And what is the range? Range is to the second element is 2, 3, -1, and 2 again, so you don't need to write 2 times. So this is this. Now you can see that this is a function, but it is not a one-to-one function. It is many-to-one function. So f is a many-to-one function. Why it is a many-to-one function? Because image of 1 is 2, image of 5 also is 2. Therefore, 2 has same image. Therefore, many has got only one image. Therefore, many-to-one function. When you are saying one-to-one function, it should all the elements of domain have different images. That will be one-to-one. If one of the element is having actually 2 images or more than 1 images, then that will be not a function. If 2 different elements or more than 2 different elements having same image, it is many-to-one function. Okay? Now, the last part says what is f of 2? Look at this here, f of 2. F acts on 2, you are going to get 3. If f acts on 2, the answer is 3. Therefore, the answer is 3. Okay, another example. Now, if f of x is equal to 3, what is this? If I draw the image, okay, 1. Find the domain and range. Okay. 2. Okay. No need of 2, just let me discuss this thing. Let's see. What is domain of this and range of this? Okay, now, what is f of 1? F of 1 is 3. What is f of 2? F of 2 is 3. What is f of a square root of 3 divided by 2? Again is 3. That is called a constant function. That means whatever you are putting the input, the output is 3. That is what it says here. F of x is equal to 3. Therefore, it doesn't matter how much is x. Then the answer is 3. Therefore, domain of this function is R. You can put any number you want, but the range is only one element, is 3. So, we call this as a constant function. Therefore, this function is a constant function. Is that okay? So f of x equal to 3 or f of x equal to c is a constant function. That means all the values of x have the same image 3. If you are drawing something like that, for this is your domain, and your range is only one element in this set. This is the range, this is 3. All the elements here, whatever elements here goes to this. Every element goes to this. So this is called a constant function. Therefore, this is many to one function. Okay. Now, let's see. If y is equal to x squared, therefore your f of x is y equal to x squared. What is the range and domain of the function? Now, let's see. What are the numbers which you can raise to power of 2? Any number can be raised to power of 2. Therefore, the domain of this function is R. What is the range of the function? Any number you are rising to power of 2 is positive. If it is negative, the answer will be positive. If it is positive, the answer also will be positive. Therefore, the range is from 0 to plus infinity. Or you can write it as y such that y is more than or equal to 0. Therefore, the range, all the values will be more than or equal to 0. You know the graph of this, you have studied, or maybe you have seen it in previous classes. The range, the graph is a parabola. Okay? Y equal to x squared, and here the x-axis, here the y-axis. All right? So you have the graph of that. You can see that y is more than or equal to 0. But x can be any number. Therefore, the domain is R, and this is this. Now, using this fact, you can do some examples on this type of this, all of them quadratic equation. If you have y equal to, for example, x minus 1 to power of 2 plus 3. Now look at this, what you can say about this. Okay, you know that any number can be subtracted from 1, that number can be raised to 2, therefore the range of this function, the domain of this function is all the real numbers. What about the range? You know that every square number is more than or equal to 0. Therefore, it doesn't matter, it's x minus some. Whatever to power of 2 cannot be negative number. So this is more than or equal to 0. So this is more than or equal to 0. When you are added to 3, therefore the answer will be more than or equal to 3. Therefore, your range will be y more than or equal to 3. Or you can write it, the range will be, range is a set, therefore you have to write set notation 3 to plus infinity. You know that this kind of bracket means 3 is included, and this bracket means infinity is not included. For sure, infinity is not a number, you cannot write as infinity. Or you can say that y such that y more than or equal to So this is the range of this function. As you may know, this is a quadratic equation, so which is because it's a quadratic one, therefore it has got a minimum value. The minimum value x is equal to 1, therefore the minimum point is x equal to 1 and y is equal to 3. Now if you draw the graph of this, you can see that the graph will be something like this. X equal to 1, y equal to 3 is the minimum point, and from here you have a parabola like that. Sorry, hyperbola like that. This is the point 1 and 3 is a parabola in this format. Okay, so to find the range and domain of a function, you should be familiar with the situation of the function. It has got a minimum value, it has got a maximum value or not. But in polynomials, we have a very nice fact which we can use it. That I will discuss about this like that. If you have y equal to ax to power of 3 plus b x to power of 2 bx squared plus cx plus d, when a is not equal to 0. Okay, this is a cubic function. Okay, this is a cubic function. The domain of this is R, and the range also is R. So for cubic function, situation is very easy. Actually, if the highest power is an odd number, therefore in that case, range and domain is always R. Doesn't matter what power is that. The highest power should be an odd number. In that case, the domain and the range will be R. The graph of this cubic function, you have got 4 different types of graph. 2 graph, each 2 of them is depend to the value of a. Now, if a is more than 0, you are going to get 2 graphs. For a more than 0, you are going to get 2 graphs. Okay, now one of them is like that, and another one is like that. Therefore, if a is more than 0, you are starting from the 3rd quadrant, from here, and finishing in the 1st quadrant. If you are sure your graph has got 3 roots, it is like that. The graph is in this format. If you are sure this function has got 3 roots. But if it has got only 1 root, we don't know. Maybe like this or maybe like this, that is depend. So we cannot talk about that. Anyway, if you have 3 roots, you can draw it like that. And then for 1 root, most probably is like this, but there are cases which looks like this is, but you shift it above. Okay? So we are not discussing about that. That can be discussed when you are finding the derivative of the function, and you can discuss what is the minimum value and maximum value. But in any case, is either of these two, therefore for a more than 0. If a is less than 0, what will happen? If a is less than 0, you have got these 2 situations. The graph is either like this, or the graph is with 3 points of intersection with the x-axis. Okay, a less than 0. Here a is more than 0. Therefore, now if a is less than 0, you are starting from the second quadrant and finishing on fourth quadrant. Again, if you have got 3 roots, therefore the answer is for sure is this. If you can factorize it, the answer is for sure in this situation. But if you cannot factorize it, then maybe this one, that is, we cannot discuss it without differentiation. All right. Now let's go for this is this. So you can draw this graph. Suppose I am giving to you y equal to x cubed plus 1. You know that x cubed is in this format because a is positive and then b is 0, c is 0, d is 1, therefore this is in this format. X cubed is like that. So x cubed plus 1, if you I will draw with red color. So this is y equal to x cubed. When you are adding 1, this graph will shift 1 unit up. Therefore, this is 1 unit up. Therefore, the answer I will draw with the blue color. For 1 unit up. Therefore, this point here will shift to this point. Therefore, your graph is something like this. That means every point, if you suppose you are getting x here, you are drawing this from here to here should be 1 unit. From here to here should be 1 unit. Everywhere this goes 1 unit up. From here to here should be 1 unit. So everywhere it goes 1 unit up. Therefore, the graph of the function is x cubed plus 1. All right. Now, let's see another example. Y equal to negative x cubed minus 2. Then what is the graph of this? Again, we start we have this our x coordinate, y coordinate. We know that this is y equal to negative x cubed. Because it's negative, it goes from the second quadrant to the fourth quadrant. Now, when you are subtracting 2, that means this graph should shift 2 units down. Okay, this graph should shift 2 units down. Therefore, I am using now blue color to draw that one. Therefore, this is 2 units down. It goes, for example, if here is negative 2, therefore it comes 2 units down to this point here. Therefore, the graph it looks like this. That means everywhere this distance should be 2 units, this distance should be 2 units, this distance should be 2 units. Therefore, everywhere the graph came down 2 units. Okay, don't look at this distance. We are not talking about this distance. We are talking about this distance. Two units down. All right. Therefore, you are having the graph of these functions. Now, when the graph shifts on x-axis, now if you have y equal to x minus 1 to power of 3, in that case, what will happen? again you are having now this is a shift of the graph y equal to x to the power of 3. Therefore, actually, if you have this graph, I will draw with the red color. This is y equal to x cubed. Now, because you have written here x minus 1, that means actually to this x you have to add 1 to reach to this. So you are subtracting 1 from x, therefore this x should be moved 1 forward. 1 forward. Therefore, you should move x 1 unit forward. Maybe I will draw it again. It's very nice. All right. Now, you can see here this distance should be 1 unit, this distance should be 1 unit, this distance should be 1 unit. Same as here. This distance is 1 unit, here is 1 unit. Okay? Therefore, your graph shifted to the right 1 unit. Be careful, students are making mistakes. When it's x minus 1, they will shift it to the left. No. This is x minus 1, that means this value of x, you have to add 1 unit to reach to this. Therefore this graph should go 1 unit ahead. Therefore, this will be, the blue color will be y equal to x minus 1 to the power of 3. You see now, if you are putting 1 here, you are going to get 0. And if you are putting 0 here, you are going to get 0. Therefore, this x here, you need to put 1 value more than the x here. That is why this graph shifts 1 unit ahead. X here, when x here is 1, is same as the x here is 0. So you are having this one. All right. Now I want to give 2 more examples of this kind, and then maybe we can stop this. You see, if you have got y equal to x minus 1 times x minus 4 times x plus 1. Now you can see that this is actually, if y is equal to 0, you are going to get x equal to 1, x equal to 4, and x equal to negative 1. Because when y is equal to 0, either of these are 0, therefore you are getting the roots. Therefore, you have got 3 different points on x-axis. And then you can see that x cubed is positive, x times x times x. Therefore, x cubed is positive, so that you know that your graph starts from third quadrant and goes to the first quadrant. But it will cross x-axis. Let me change this one to here. Okay, this will change our x equal to negative 1, x equal to 1, 2, 3, 4. Now, we know that our graph starts from here, goes here, and goes here. So, you can see that if you start from here, go up there, come back down here, and go back down here, and then come back up. All right? So, you have got your graph like this. We can find this very simple. This point is 4 actually, and then how much this goes up and down, you need to find maximum, minimum, which you have studied in your secondary, upper secondary, and you know you have to know differentiation. But we are not going to discuss about that. Now we know the graph roughly is like this. All right. Now I want to give one more example of this kind of this. When there is a, suppose I have minus x plus 1 power of 2, sorry, no power of 2, for the next one. X minus 3 to power of 2. Now, what will happen here? If you are putting in y equal to 0, easily you can understand from this you are going to get x equal to 1, and from this you are going to get x equal to 3. Now you can see that you have got 2 points of intersection, but one of them is a repeated root. Is a repeated root. We call this repeated root. That means x minus 3 is equal to 0. You are going to get answer twice. Therefore, it is called a repeated root. Okay. What will happen to what will happen here? And also you can see that here this is negative, x squared is always positive, then multiply this is negative, therefore the coefficient of x cubed is negative. Therefore your graph will start okay, since x cubed is negative, therefore a is less than 0, therefore your graph starts from somewhere here, then finishes somewhere here. So we know this. Now let us try to check. We know that at x equal to 1 is one of the, and x equal to 3 is the second one. This is x equal to 3. Now, we know that the function starts from here, goes down here, goes up here, goes down here, and up here. Now, okay, should I discuss something here first? You see that, let us go start from here. We need goes down here, comes back here, then goes back down here. You see, because this is a repeated root, there is a repeated root, therefore it will touch x-axis, but it doesn't cross x-axis. Because it's a repeated root, that means in the neighborhood of this tree, in this area, the sign of the function should not change, because this is always positive. If this part is negative, therefore this will remain negative. So when you are reaching to repeated root, wherever you are, you have to turn back and go up. If suppose this is a repeated root, you are coming like that, therefore you are reaching to repeated root, you have to go back. If this is a repeated root, you are coming and touching the repeated root, you have to go back down. You cannot cross the x-axis. If it is simple root, same as here, 1, then you can cross the x-axis. So whenever you are reaching to a repeated root, then you have to turn back and remain in same quadrant. If it is simple root, you are crossing the x-axis and you are going to the other side of the x-axis. Other side of x-axis. Wherever you are, doesn't matter. I think this was useful for you, and if you have any question on this polynomial graphs, we can put in the comment. I will come back to you. Thank you for your